simplify the integral of 1 over x squared minus 5x plus 6. Okay? So we've got 1 over a quadratic here. Okay? And actually, my experience tells me we can factor this quadratic. I'm going to use the partial fractions decomposition setup. Okay? So first thing we're going to do, we are going to factor our denominator here. X squared minus 5x plus 6. We can turn that into x minus 2 times x minus 3. How do you do that? Can you find two numbers that multiply to 6 and add to negative 5? You betcha. Okay? So we're factoring here. We've got nice, distinct linear factors. Okay? And that informs how we're going to do the setup for our partial fraction decomposition. Okay, so we go over here. Here's our function. We got 1 over x squared minus 5x plus 6. And we had x minus 2 and x minus 3. For each of these linear factors, we assign them their own constant. And we set this up. This whole thing here is what we call the partial fraction decomposition. It allows us to trade the function we're trying to integrate for a sum of much simpler, easier to integrate functions. Like a lot of integration techniques don't outright answer the question, but they trade it for something simpler. And that's exactly what's going on here. Okay, so what do we do next? We got to find a and b, right? We set things up. That's like step 2. Now we got to find these constants a and b. How do we do that? So I find the best way, it's not the only way, but I find the best way to do this is to multiply both sides by x squared minus 5x plus 6, although you might choose to write it in its factored form. Okay? So if I multiply on the left by x squared minus 5x plus 6, you're just going to be left with 1. Okay? If I multiply each of these terms by x squared minus 5x plus 6, it cancels out with the factor on the bottom, just a little bit. All right, we had b over x minus 3, but now we're multiplying by x squared minus 5x plus 6. Well, the x minus 3 factors cancel out. So left with 1 is a times x minus 3 plus b times x minus 2. Now, again, there's a lot of things you can do from here. Okay? I find it's most effective when we're dealing with sort of distinct linear factors like we are here to just say, okay, what would make x minus 3? What value of x would make that equal to 0? And plug that in on the left and the right. Now, on the left, you're just going to have a nice little constant of 1. But on the right, you'll get some expression just involving b. Okay? This isn't the only way to do it. You could expand this out and compare the polynomial on the left and polynomial on the right. Okay? But I find it's really easy if you just plug in values. So let's let x be 3. Well, then 1 is going to be a times 3 minus a plus b times 3 minus 2. Well, that's 0, so that goes away. 3 minus 2 is 1. Oh, look at that. B must be 1 in our partial fraction decomposition. We can pull the same trick and let x be equal to 2. So we got 2 minus 3 plus b, 2 minus 2. We choose that 2. Why did we choose that 2? So that it makes the x minus 2 factor 0. And that way we don't have to worry about b. And we just say, okay, 1 is negative 1 times a. So a is going to be negative 1. Well, there we go. There we've got our partial fraction decomposition. We are able to rewrite, what was it, x minus 2 there. We're able to rewrite our rational function as a sum of these simpler rational functions. These are going to be easier to integrate. Okay? And now the last step of the whole process is to actually go ahead and integrate. So we make a little switch. Okay, so it's minus 1 over x minus a plus 1 over x minus 3. But we can split this up, right? Sum rule and then constants coming out, so we can split these up here into 2. Like it's trading one integral for 2, but these are much simpler integrals. Much simpler integrals. And we can actually integrate them fairly quickly. Minus ln absolute value of x plus 2, and then this one goes to just ln absolute value of x minus 3. And we're done on indefinite integrals, so don't ever, ever, ever forget your plus c. And we're done.